Hey, this is Mr. Janes. In this video, we're going to be talking about some basic Polygon vocabulary. Now, you may have seen some of these words in middle school or maybe even elementary school, and some of them may be new to you. In any case, please copy down all the different vocabulary words. We'll talk about them and use them a little bit, and then make sure you understand them or at least have the note sheet with you for next class, because we'll be taking a video check and then starting our lesson based off of these words. It's very important that you finish this to the end, and this won't be too long. So let's start off. What is a polygon? Okay. Well, a polygon is a closed plane figure with straight sides. So that means that something like a triangle, right, is a polygon. Squares are polygons. But something like this shape would not be a polygon because it is not closed. Something like this would not be a polygon because it does not have straight sides. And a cube, okay, would not be polygon because it is not a plane figure. Plane means it sits flat on a plane. It's two-dimensional. So none of these are polygons. None of those. But these two are. Okay, that's what a polygon is. So how do we name polygons? Let's say we look at this shape right over here, and we want to somehow name it. Well, what we're going to do, all right, there's the bell. What we're going to do is name it by using first what kind of polygon it is. It has 5 sides, so it's going to be a pentagon. And then we use all of the letters going around the outside, the vertices. So we would call this pentagon B, C, D, E, A. We could use another letter to start. We could call this pentagon D, E, A, B, C. And we could go backwards. We can call it pentagon D, C, B, A, E. As long as we're going in order around the outside and naming all of those points, all of those vertices. For a triangle, it's basically the same. We should have one slight change. We're allowed to use this little triangle symbol for a triangle. So this would be triangle RSP, and we could have called it triangle RPS or triangle PSR. As long as you've got 3 vertices going around the outside, the little triangle symbol in the front, you're okay. Now I have interior and exterior angles. So you can probably take a guess at what an interior angle is. An interior angle is just an angle on the inside of a polygon. So something like this angle is an interior angle. This angle is an interior angle. From before, this angle are interior. Or maybe this angle or this angle. Those are all interior angles, right? As long as they're on the inside, okay? Formed by the 2 sides like that. So it's an interior angle. We also have exterior angles, which are a little more complicated. They're formed by a side of the polygon and a ray on the outside of the polygon. So if you had something like this shape right here, your exterior angles are formed by a side and this ray from the outside like that, and this is your exterior angle. What would that look like in other shapes? Well, if I drew, I don't know, some sort of quadrilateral, okay, my exterior angles would look, okay, something like this. That's one, that's another exterior angle, that's another exterior angle. If you're familiar with cameras, you might notice that this looks a lot like the aperture of a camera, right? The inside of a camera, that spot where it takes the picture, okay? But those are all exterior angles. And we'll talk about how to use them a little more in class. But it's important that you know just what they are. Okay, so we've got interior angles and exterior angles. Again, exterior and interior. One more time. Exterior and here's another interior. Okay, interior, exterior. We've got a few words: equiangular, equilateral. I'll give you a hint on these. Equi means the same. So what do you think equiangular means? Equiangular means that all the angles in that polygon are congruent. So I've drawn an example right here where they're all 90 degrees. You could have another example of an equiangular triangle, where all of the angles in a triangle are the same size. Maybe they're all 60 degrees. Okay, that's what equiangular means. But equilateral, think about this. Equilateral means sides. So an equilateral polygon is where all the sides are congruent. So for example, there's an equilateral quadrilateral. It's got 4 sides. Here's an equilateral triangle. Okay, it's got all of its sides are congruent. So that's the difference between equiangular and equilateral. Angles are congruent, or all sides are congruent. Okay, so we'll talk about those a little next class as well. What's a regular polygon? That's a little different. Well, a regular polygon is a polygon that is both equiangular and equilateral. All the sides are congruent and all the angles are congruent. Okay? So here's an example of a quadrilateral. A square is a regular polygon because all the sides are the same and all the angles are the same. Here's some more examples over here of regular polygons. All of the sides are the same, and not just that, but all the angles are congruent. Okay? So that's a regular polygon. Here's another, right? All of the sides are congruent, and all of the angles are congruent in this polygon. Okay? That's what regular means. A couple more before we finish this page. A reflex angle. Now, we've learned about this before. You might be familiar with it. Reflex angle is an angle that is more than 180 degrees. So it's kind of like this outside part of the angle there. Okay? And so in a polygon, if we're talking about this angle here, this interior angle, we would say it's a reflex angle because it's going past 180 degrees. It's going way past it to be a reflex angle. So on our note sheet, let's write that down. The reflex angle is an angle that measures more than 180 degrees. Now, why is that so important? Well, it's important to know what a reflex angle is because it makes the difference between what a concave polygon is and a convex polygon. Do you already know what the words concave and convex are? You might know that concave means to bend inwards and kind of make a cave, whereas convex means to bend outwards. And so a concave polygon is one that looks like this. A polygon with one or more reflex angles. Okay, so there's a reflex angle right there, and it's kind of got this cave, right? Concave. On the other end, a convex polygon is one with no reflex angles. It looks kind of like a normal polygon, kind of like some of the ones we've seen before. It doesn't have any of those inlets, those caves, no reflex angles. Okay, that's concave and convex. Okay. So if you need to pause the video to write down any of these things up here, or pause the video to write down anything down here, and skip this stuff for now. We're going to skip this and go straight to the back side. All right, we're on the back side of our paper now, and we're skipping all the way down to the bottom where it says number of sides and name. What we're going to do is go ahead and name the different kinds of polygons we're going to be working with. You can probably name a few of these right off the bat. You know that a three-sided polygon is called a triangle. Tri meaning three. You might know that a four-sided figure is called a quadrilateral. Quad meaning four. See if you can fill in as many of these as you can from memory. Pause the video here and see if you can fill in as many as you can. All right, let's see how many you got right. A five-sided figure is called a pentagon. Penta meaning five. Think of the Pentagon. There's a building actually in Washington, D.C. called the Pentagon. We'll look at it in a second. A six-sided figure is a hexagon. Hex meaning six. There are such things as hex bolts and hex nuts that all have 6 sides. A heptagon is 7. Hepta meaning 7. Octagon meaning 8. Octopus, right? That's 8 sides. 9, nonagon. Nona means 9. Decagon is a 10-sided figure. A hendecagon, now this is a new one for a lot of people, is an 11-sided figure. And a dodecagon is a 12-sided figure. Past 12, there are special names we could use, but instead we're just going to call them an n-gon. So if we have maybe a 14-sided figure, we're just going to call it a 14-gon because we're not going to bother to learn that big of names. So after that, just call it a 14-gon, a 15-gon, what have you. But these are 3 through 12. Pause the video here if you need to write them down. So here's some quick examples of different kinds of polygons. All of the ones we have here are regular. What does regular mean again? It means that, remember, we have all the same length sides and all of the angles are congruent. We've got our triangle, our quadrilateral, our pentagon, 5 sides, our hexagon, 6 sides, our heptagon, 7 sides, our octagon with 8 sides, our nonagon with 9 sides, and decagon with 10 sides. You don't have to write these all down, just kind of look at them and think and kind of take it in. Again, they don't have to be regular. Oops. They don't have to be regular. Okay? They could look like this hexagon. Would that hexagon be concave or convex? In fact, how about all of these? Are these concave or convex? Well, the hexagon, that's convex because it has none of those reflex angles, none of those caves. But all of these are concave, okay, because they've got those reflex angles, those kind of caves going on there. Okay, this is a reflex angle right there. This is a whole bunch of reflex angles. One there, and there's a few more. Polygons are everywhere, right? This is the Pentagon, okay? The defense building in Washington, D.C. It is a pentagon because it literally is a regular pentagon. It has 5 sides. We've got what looks like a quadrilateral here. We've got ourselves a triangle, and then this has 1, 2, 3, 4, 5, 6, 7 sides. So what would you call a 7-sided figure? Is that a heptagon? That's a heptagon. We've got a hexagon here with a nut. We've got one of these. Ooh, count how many sides that has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's an 11-sided figure. That's a, what do we call that? That's a hendecagon, okay, on the Canadian dollar. Got an octagon on our stop sign with 8 sides, a regular octagon. And we've got hexagons on our soccer balls, right? So polygons everywhere. What I want you to do is pause the video here and try and label all of these figures, 1 through 6, and these 2 as well. What would we call them? Be as specific as possible. Use the words pentagon, heptagon, hexagon, but also words like regular, equilateral, concave, convex. Okay? Try and think of as many names for these as you can. Pause the video now. And here are some answers. This first one, we can call it convex because it's got none of those caves, and also it's a quadrilateral because it has 4 sides. Number 2 is regular, well at least it looks regular I guess, because all the sides are about the same length and all the angles look to be congruent. And it's an octagon because of 8 sides. Again, for 3 we have a convex heptagon with 7 sides. A concave pentagon, remember it's got 5 sides, 1, 2, 3, 4, 5, but it's got this little inlet there, that cave, with a reflex angle. Okay. We have a concave? No. That is convex. I'm sorry, convex, because it's got none of those reflex angles. All of its interior angles are obtuse, it looks like. It's equilateral, because I marked all the sides were congruent. And it's an octagon, because it has 8 sides. Over here we've got a concave, definitely concave, with those reflex angles there. Heptagon, okay, 7 sides again. We've got an equiangular, because all the angles are equal. Hexagon, 6 sides. And a regular dodecagon. It's got 12 sides, and it looks like all of those sides are congruent. I didn't mark them congruent, but we can probably take a guess that looks pretty regular. This is the end of our video. All vocabulary words that you learn in this video we will start to use next class. You don't have to have them memorized, but you do need to know how to use them pretty well. We'll take a video check at the beginning of next class. Don't forget to go back, rewind if you need to, and I'll see you next time.